right. We still have this exercise to finish, so you still have these few questions to finish off. So we can carry on and do equations. So here is what we have. And if you remember what I taught you a few days ago, I said you can get rid of numbers easily by picking the expansion that has 1, a positive 1. So in this situation, these are your identities right here. So cos 2x, in this situation, you should be able to pick this one. And the bottom one is the same all the time. So let's keep that one going. Right, besides, you really wanted to have tan, and tan is sine over cos, so you had more reasons to pick this one in this particular question, although of course you were trying to cancel the ones there. So since the ones are going, you can see that we still have 2 sine squared x on the numerator and 2 sine x cos x on the denominator. And of course, if things cancel, you should do that in a hurry so we can see what to do. So one of these ones will be cancelled by sine x. Oh, and we also have 2 cancelling right there. So it means on the numerator we are left with sine x, and on the denominator we are left with cos x. This is a well-known value. This is certainly equal to tan x, just like the right-hand side, going in a straight line like that. So that is 1.5. Like I said, we want to try and finish these ones in this video, although it will most probably be too long. But let's try to move a bit fast. Since we are used to these things now, at this stage you should find this kind of work very simple. So I'm going to take cos, it's cos x plus sine x squared minus 1, and it is those 2 brackets down here. They say that we must prove that this whole thing is equal to tan 2x. These are the questions that were left on question 1. So let's see what was expected of us here. And as we are seeing now, after you do a few sums, you will start finding this work very simple. You know it's tan 2x, so we want to try and get to sine 2x over cos 2x. You know, that's where we're going to try and get to. So what we have here, if it's possible, if we can get sine 2x in any way on the numerator and cos 2x on the denominator, then we'll say it's easy. And at the denominator, you can see this one is a difference of 2 squares. It should come down to cos squared x minus sine squared x, which will give us cos 2x. Now the whole point is to try and get sine 2x from here, or rather 2 sine x cos x. So I am going to have to FOIL this one because we will not be able to see our sine 2x easily from here. So I'm going to do this. You know how to get rid of those brackets. So 2 sine x cos x will be the middle term, is these 2 brackets multiplying. And of course there is sine squared x here. Let's not forget the minus 1. While we are still at it, let me also FOIL this one. Since it's a difference of 2 squares, all I said was you just square that one and you square that one. It's the fastest way of foiling that one because you know the middle term cancels. Except you just have to maintain the negative right here. So this is what you get if you know it's a difference of 2 squares and it's this one. Right. How then are we going to get to the answer? So firstly, let's agree that cos squared x plus sine squared x will give us just 1. And if you are here, you will notice how 1 minus 1 will cancel. So let's not do all the steps like 1 minus 1 certainly will cancel, and this one here is what's remaining. So let me just do this. This reminds us of sine 2x, does it not? This one. And then the minus 1. And then this one here at the bottom, reminds us of cos 2x. I put these ones down here so you can occasionally look at them to see which identity I am using and at what time. So as you can see, this will be just sine 2x and cos 2x left, which will be equal to tan 2x, just like the right hand side. So you'll find number 1 is now done. Everything on that one is done. So you should be able to solve any one in that exercise. If you didn't, well, then do your corrections and make sure you are sorted. Well, let's see about question 2. I found question 2's questions were rather, if you did question 1 correctly, question 2 is not even a problem either. So let's go and do 2.1 as fast as possible. Let's do these ones. Okay, that one, of course, now that one is super simple, especially if you have been learning your compound angle identities. We are here on this one. In place of alpha, there is x, and in place of beta, there is y. So we are expanding using this one. After some time, you won't have to look at these formula, but I put them for you. So make it a point that you use them if you still have to use them. So the left-hand side, like I said, I'm going to expand that one. And then that should be plus, that's cos x, sine y, all over cos x, cos y. Now, for this one, notice how you have one term this side, and then you're supposed to split it to become 2 terms. What I would normally say is, if you started on the right hand side, you have sine over cos, sine x over cos x, and then sine y over sine over cos x. Those will be 2 fractions. What I will first of all say is, put them under one denominator and then make sure that it's 1 term. But in this situation, we're coming from 1 term, trying to get to 2 terms. So we do exactly the opposite. Instead of taking the fractions together, we're actually going to split them. What I mean is, since there are 2 terms on the numerator, you can really just split them and say this over that plus that one over this. I hope you agree, because let me just say we had 5 over 7. It's the same as saying, 2 over 7 plus 3 over 7. So you can, this is when they are added. It's like your 5 can be written as 2 plus 3. So you can really split them like that and it will still be correct. So that just checking if you, because other people usually have a problem here. So I hope you're not experiencing any problem there. And as you can see, this one will cancel. And even here, that one will cancel. We have our 2 terms as we were hoping. So you may want to just write this step, but I find it's really unnecessary because we can see when you cancel, but just to be safe. Then, of course, this one is what you change to tan x, and that one you change it to tan y, like the right-hand side. So copy that one, and if you got it right, I am busy clapping your hand, my hands for you, inside. So we have sine 2x over sine x that is equal to 1 over cos x. Okay, so this one again is not a big issue, because at this point we have already appreciated how we move from two terms to one term, and perhaps from one term to two terms. It should be very, very simple. So here we are taking it under one denominator, and we have explained this one well. I think you remember it. Since these are unlike terms, no common factor at all, we're taking them as they are. And if I take them as they are, remember I said you just multiply. So it is sine 2x multiplying cos x, and cos 2x should be multiplied by sine x. You know, you have to always write that left-hand side thing so you can say it is equal at the end. So at this point, you don't have to go horizontally, we don't have space. This one is saying sine cos cos sine with a negative. Look, it's obviously this one, sine cos cos sine. You can see it's an expansion for alpha minus beta, and in place of alpha there is 2x, and in place of beta there is x. So let's simplify this one using compounding or identities. I'm going to put 2x over there in place of alpha, and of course with a negative sign, like that. Then we still have sine x cos x. Well, luckily we can still subtract 2x and x, so that will now become sine x on the numerator, and it's still sine x cos x down here. If we have something that's common, please, we won't keep it for that long. We have to cancel it. So this is going to be equal to 1, let me rather put an equal sign for real, 1 over cos x. And forgive me, I'm going to go horizontally here, which is of course equal to the right hand side. You should have calculated, this is 2.2 from right here. Simple, totally simple. Good. Let us go. 2.3 should be simple to do as well. I'm going to erase this part. Try to follow. Right, then we have 2.3. Let's write that one quickly. Let's answer them as fast as possible. This one right here, the only problem is that those are the long ones where you do some long stuff, but otherwise it's not a problem at all to solve this. You should also be able to do this one. The angles are forming a difference of 2 squares, which is very tempting to do anything, but unfortunately there is nothing we can do at this point except we have to expand it. So I'm going to expand my left hand side from here. And notice if it's a plus, I am using this expansion here. So you can look at the expansion and see my substitutions. So it will be sine 45 cos x, and then we put a plus and then we say cos 45 sine x. That's the expansion for this one. But don't forget, it's being multiplied by that one. So again, I'm going to expand that one. It's not a big issue. Just remember, the sine function takes the sine as well. Now, although the angles were doing that, even now here, this is a difference of 2 squares we can respect, not what we were looking at there. This one right here is a difference of 2 squares, and from what I taught you before, you just go to the negative bracket and you square that one. Otherwise, you spend a long time foiling this one. So all I'm saying is square that one. It will be sine squared 45 cos squared x minus, then you also square that one, cos squared 45 sine squared x. It works anyway. That's the correct expansion for these brackets. The middle terms, we know how they cancel already. So don't forget, we're trying to get here. So this guy is not needed at all. That one is a good thing. So let's put our special angles. Sine 45 from the triangle or from your head, wherever it's coming from. We don't really mind. Let's change it already. We don't need it. I'm going to change it to 1 minus sine squared x. You know that we can do that from the identity that says cos squared x plus sine squared x is equal to 1. If you make cos squared x subject, you should get this. Okay, so this one again is 1 over root 2. It's being squared multiplied by sine squared x. We want to keep this guy. Okay, so this one is 1, that should be 2. This again is 1, and that's just 2, sine squared x. Some steps are really annoying to do, but we just have to hang in there and do this thing. And minus half sine squared x, that's us removing that bracket, and now taking like terms together. The half is still here, but these two are like terms. Minus half minus a half will give me minus 1, so it will be that right there. So this, people, is the solution we were looking for. So that is number 2.3. Make sure that you understand every step there. It's just long. That's the only thing. If you can move from here to there without making mistakes, everywhere else you should be able to answer. Okay. Let us see if we can carry on. Oh, they are very similar, these ones. 60 plus x. And then you also have cos 60 minus x is equal to 1 quarter minus sine squared x. Okay. Okay, I think after we finish doing this one, you should not have a problem with this one. This and this are practically the same question, just asked differently, with different functions. So we are going to expand this one. So let's do that one first. Did I forget to say equal to the right hand side? Or we can say quite easily done. Don't do it. Okay, so here it's cos 60 cos x. I'm expanding this one. I am pretty sure you are looking at this expansion to do this, because alpha is replaced by 60, beta is replaced by x. So let's carry on. Cos 60 cos x, and because there is a plus, I'm going to put a minus. Sine 60 sine x. That's the first one. Then let's go to the second one. They are multiplying these guys. So it's cos 60 cos x. Now, because there's a minus, I'm going to put a plus. Sine 60 sine x. Easy peasy. Again, we are on the difference of two squares, and like I said, if you have a difference of two squares, don't stress and do all sorts of things. Just go to the one with the negative sign. You square this term, square that term, and maintain this negative. So it should be cos squared 60 and cos squared x minus, square this part, sine squared 60 sine squared x. Like that. These are special angles, so we don't want to waste time on them. cos 60, from what you remember from your triangles, it should be a half. Then it's cos squared x. Let's see if we still need this cos squared x. We can get rid of it now. We don't need it. So I'm going to actually write 1 minus sine squared right now. You know, at times you start wondering if people are following because you're not here to ask me. So remember, this is what I'm using. You know very well that it is equal to 1, right? So I am saying cos squared x is 1 minus sine squared x. This is what I'm using. In case you forgot, I'm using it right here. So that is what we have. So it's 1 minus sine squared x. In place of that, I'm getting rid of it because I can see I don't need it on the right hand side. Sine 60 is well known to be root 3 over 2. Let's square that one quickly. Okay, so now we have a quarter here. And then we seem to have 3 here and over 4 sine squared x. So 1 quarter minus 1 quarter sine squared x minus 3 quarters sine squared x. Okay, good. I think you're noticing what I'm noticing. This 1 quarter is on its own, but these two here are like terms. So I am going to have to take them somewhere together. I'm going to say that's 1 quarter, this one, minus 1 quarter minus 3 quarters, that's minus 1. So it will be minus sine squared x, just like the right hand side. Okay, this one was very, after we did this, explaining this one and understanding this one should be very simple. Okay, so let's finish off this thing. Let's finish off this thing. There is 2.4 as well. Let's see what's happening there. Let's do 2.5. We're getting there now. It's 2 cos 6x. Let that one. Cos 6x cos 4x. That one is rather interesting. We're going to have to get rid of all this until we get 1. But it calls for you to think a little. There is sine squared. If there could be some cos squared somewhere maybe, then we'll get 1. And this does look like a compound angle identity, but it's not there anymore. 10, 10. It should work this way, so it should work. Let's see, 2 cos 6x cos 4x. If we change that one to 6x plus 4x, is the way I'm noticing my work there. It should work. Yeah, let's go. I don't see my future from here, but let's just carry on. Let's expand that one. It's cos 6x, cos 4x. You put a minus, sine 6x, sine 4x. I expanded that one. All I did was to change 10x to this so I can use compound angles to do this, because I'm noticing these angles are available, forcing it to become a compound angle identity. Hope that works. And then that we have plus 2 sine squared x. Oh, good. Good for us. Notice how this is exactly equal to that. They are like terms with this one. So we can subtract them. 2 is like 2x minus x. Of course, you'll be left with just 1. So I'm going to write cos 6x cos 4x, since one of them is cancelled by this one. But this negative is going to make that one positive. So I'm going to write it as sine 6x sine 4x positive. There is still that plus 2 sine squared x that we have to keep with us all the time. Seemingly doing nothing there. Okay, good, good. This one now is a compound angle for cosine. It's saying cos, sine, sine. So definitely it's a cosine, and it is the one with a plus. So what I'm saying is, look at this expansion. In place of alpha, there is 6x. And in place of beta, there is 4x. So that's what we just have to do here. So this whole thing from here to there, this whole part, all the way from here to there, to be equal to cos. Remember, like I said, in place of alpha, we put 6x. In place of beta, we are going to put 4x. Okay, that's plus 2 sine squared x. And of course, this here, 6x, oh, beautiful. Now we are back again to the double angle identity for this. Plus 2 sine squared x. What do we need? What do we need again? We need a 1. So I'm thinking let's cancel this one by bringing the double angle identity that will cancel this thing. It should be this one. This one, the one that says 1 minus 2 sine squared. I would like to use that one quickly. So if I go and say 1 minus 2 sine squared x here, and say plus 2 sine squared x, you will notice how those two will cancel each other out, and you'll be left with 1, just like the right hand side. Okay, it wasn't tough at all. It was very simple, right? Are you agreeing? It was rather different, that one. I should believe in that. Okay, let's see now if we can finish off this exercise. This is the last question. Just hang in there. It's the last one. So of course, let's have 2.6 right there. Let's see what it is saying. The rest of these are very simple, and we have done questions that are similar to them, so you'll find them very simple to do. So this one, let's reinforce our skill here. Okay. We should be reinforcing this same skill because these two are similar. You can see how this one was 6x and 4x, and we had 10x. Now we have 5x, 4x, and now it's 9x. Of course, it's giving itself away, is it not? So this is the left-hand side. I'm going to keep this one where it is, just as reinforcing the skill we learned now. And from what I say, just express this one in terms of the angles you're seeing here. Let this be 4x. Let's maintain that. Okay, like that. And let's move this in the negative right there. So I do not have much to do except I'm going to keep this one and say minus. I have to expand this one. And I am definitely using this one. In place of alpha, there is 5x. In place of beta, there is 4x. So I'm going to expand that. And we still put a plus. There. Like we did the other one. The other time, it's this one and that one, like terms. Let's subtract. This is like 2k minus k. So we are just going to write this whole thing. One of them was subtracted out by this one, so we'll be left with just 1. Then this negative, we change that one that was positive into a negative. I think you're following very well here. Nothing to get lost on. And now it's saying sine, cos, cosine. If you don't remember where we saw that before, let me show you. Sine, cos, cosine with a negative. It's an expansion for sine alpha minus beta. So just know what is in place of alpha, what is in place of beta. So this is the same as saying sine 5x minus 4x. And of course, this will be sine x, just like the right-hand side. So please, people, this is identities. It's nothing serious at all. You will be able to prove all the identities now. Wait until we do the examination revision, examination type of questions, some place later on, unless you see those videos. Okay, thank you.